I have been playing with the concept of wireless transmission of electricity using the Joule-TIFF circuit. The idea comes from a video by Slayer2732. The circuit is identical to the Joule-TIFF, only you have to make a pancake coil with a 2-wire cable like this. In this case we have a red and a white wire in the cable. What you have to do is to connect two different wires from each end of the coil. In this case, the white is connected to the red. In this way, you will have 3 wires coming out of the coil, and I will now show you how to connect them. The coil has 18 turns. Here's the diagram. We see that one wire in the center of the coil is connected with a wire of the other color in the other side of the coil, and these two go to the positive of the battery. The other wire in the center goes to the resistor that goes to the base of the transistor, and the other wire in the other side of the coil goes to the collector. The emitter of the transistor is connected to the negative of the battery. The transistor has pins, base, collector and emitter. Here we have the white wire connected to the red, and these two will go to the battery positive. The red wire in the center goes to the resistor and to the base, and the white goes to the collector. The emitter of the transistor will go to the negative of the battery. Let's try the system with 12 volts of input. I'm going to use this LED connected to this coil of magnet wire. It has 20 turns. And there you are. It works at a distance of up to some 16 centimeters. And let's try also with this broken lamp. I have connected this coil to the LEDs, and let's power it up. As you can see, all the LEDs are lighted. The range is about 8 centimeters. Let me try also with an incandescent lamp. This requires much more current than the LED. It is connected to this coil, and let me apply the input voltage. As you can see, let me move the coil. There you are. We can also run small motors like this. This comes from a CD-ROM player. The motor is connected again to the coil, but we have added a diode in order to rectify the current from the coil. So let me again connect the power, and there is the motor running. I'm going to measure the DC volts of the system. I have connected the multimeter to the coil using a diode to rectify the voltage. I'm going to connect, and we can see about 19 volts. Let's now check the current that the system produces. I'm going to put the multimeter in current and apply power, we have 0.43 amperes. For these tests I have been using this large battery. It may be overkill, however the system needs about 1.5 amperes of input. We can also run it on a smaller battery like this 9-volt battery, and it also works, as we will see now. I'm going to run now the system of the 9-volt battery. Let's see how it works. It has less power, of course, but it still works at a pretty good range of about 12 centimeters.